These are a couple of rectifier diodes which can be used to convert AC to DC. This region is the cathode and this region is the anode. The cathode is marked by a ring. You can see a small ring, white ring here. Here also the ring is there, though it is a little more faded. So this will be anode and this will be cathode for the diode. Diode by definition allows current to transfer only in one direction. And by notation, current in an electric circuit is from anode to cathode. Though actually the flow of electrons is from cathode to anodes. Conventionally it has been designated that the current flow is from anode to cathode. So these are a couple of rectifier diodes. Now we will see how they are used in rectifier circuits. We saw that cathode is marked by a ring on the actual device, and this is the electronic symbol of the anode and cathode. This is the anode and this is the cathode. The corresponding semiconductors are like this. It's a PN junction which allows transfer of electrons only in one direction. This is positive type, P type, and this is N type semiconductor. So this is a PN junction in this diode, and this is used for rectification. This is a transformer which is shown here, primary winding and secondary winding with the core in between. Here giving an alternating current here. Sinusoidal alternating current waveform is fed into this primary, and secondary also will have an alternating current. Only difference, depending on the turns ratio, the voltage will be different. This is like a step down transformer I have shown. You can have also step up transformer. And this circuit uses only a single diode. So the lower half of the alternating current will be cut off by this diode when it goes into the load. Load is a resistor. So you will have only the upper half of the current flowing through the diode. That is rectification. So as one of the waves are cut off, it is a half wave rectifier. Only the positive cycles are sent out into the load. That is a ripple like, intermittent ripple like current which flows into the load resistor. That is half wave rectifier. Output has only half of the waves in the input. If you connect the output of a half wave rectifier into a loudspeaker, you will have a ripple sound with 50 Hz frequency. That is what is the output current of a half wave rectifier. If you connect it to an oscilloscope, you can see the pattern there as I have shown in the drawing. Now this is a full wave rectifier. This is a transformer again. A difference in this transformer is that secondary has two sets of windings, or rather it has a central tap. CT is central tap. There will be windings in this side and winding this side, so that the current fed to each diode will be 180 degrees out of phase. Direction is different. And center tap goes to the part of the load, and the output from the two diodes are combined together and given as the other pole. This is full wave rectifier, because during one half of the cycle current will flow through one diode, and during the second half of the alternating current cycle current will flow through the other diode. That is why it is called as full wave rectifier. The output form will be better. This will have the double frequency sound if you connect to a speaker. That is, if you are connecting 50 Hz supply, then it will be a 100 Hz. That was one type of full wave rectifier using diodes. Now there is another known as, this is the bridge rectifier. Bridge rectifier, where a bridge of 4 diodes are used. The advantage here is that you don't need a center tap for the transformer. A simple transformer is used without center tap, and the diodes are connected in such a way that it behaves like a full wave rectifier. So this is another way of implementing full wave rectifier. The output will be same pattern which I have shown earlier. Now, as the output of rectifiers have ripples, that has to be smoothened out. That can be done by putting a capacitor across the output. A high value capacitor, typically 1000 or 2000 microfarad capacitor, can be connected across the output. Then the ripples will be smoothened out. If you want to still smoothen out, an inductor can be connected in series here. Then it will be still smoothened out. Most basic rectifier circuits use only capacitors, and if you want a perfect near direct current like output, then you can use inductor in series as well.